For this project, I built a machine learning model to predict the net hourly electrical energy output of a combined cycle power plant using ambient environmental data. This is a supervised learning regression problem because we are predicting a continuous numeric outcome using labeled historical data. To evaluate performance, I will be using the root mean squared error because it measures prediction error in megawatts and it gives more weight to larger errors, which is appropriate for this use case. There are 9,568 rows, and before modeling, I split the data into test and training sets, using roughly about 80% for training and 20% for testing. The training data will be used to fit and compare between the two models, and the test set will be kept completely separate and only used at the end to assess how well the final model is. I first started with a multiple linear regression model in Excel as a baseline using all four environmental variables as predictors. This baseline model explains about 93% of the variance in power output with a standard error of about 4.6 megawatts. In Excel, this standard error is effectively the RMSE on the training data. So this will be what I'll be using to compare the models at this stage. To improve accuracy, I then built a second model using polynomial regression. Very specifically, I added squared terms for temperature and exhaust vacuum, which allows the model to capture nonlinear effects that might have been missed out in the previous simple linear model. This model performs better than the baseline with higher explanatory power and lower error, so I selected this as my final model. After selecting the final model, this. I evaluated it on the held out test set, and finally using RMSE, this model achieved a test error of about 4.28 megawatts, which is very close to the training error, and suggests that the model generalizes well without overfitting. That is all. Thank you.